Okay, we're recording the meeting because we'll probably take just a few notes, and we will be able to send the meeting also to Jeffrey, who actually being in Shenzhen with something that sounds like cold or flu symptoms is currently at the doctor being checked. And my heart goes to him because it's probably extremely stressful. So this is not going to be a very long meeting. I can see that we have a subset of the group. I guess I would call it, it's quality, not quantity. There's been a lot of stuff happening in our little, it's very funny because coin in French is corner. So I think in our little corner of the world, there's lots of stuff happening. There's a lot of good work being done. And I think Jeffrey, Eve, and I wanted to have this interim to make some statements about what is happening. We are still very much, I would say, still in a startup mode. We are looking for new work, and I forgot to mention security, but I'm going to add it when I speak. We are obviously preparing for Vancouver, although the hackathon is not the big point of this group. It's still, I think, a fantastic way of getting together with the other groups. It's probably the only time during IETF, IRTF, where both the research groups and the engineering groups can meet and share. So I think the participation to the hackathon is as much for a face-to-face social interaction as much as doing great code. So you can go through the next slides, which is all the policies, the intellectual property, and the goal, the harassment and everything. So this is an interim meeting. It is recorded. It has been planned, so it is considered a proper meeting. So you can go to the agenda, please. Yeah, the goal, so that's it. Okay, go. Yeah, we can just reply. This is actually, yeah, the previous ones, COIN is still looking at everything that's happening in the computing and the network. And as I said, for me anyway, in the past 3 months, there's been so much activity. There's been so much work being done that is related. And while I think that when we started this group, there was a strong link on, what are we going to do with the data centers and the edge? Is it going to be both? Is it going to be in between? Is it going to be just switches for filtering in the P4 world? But I think that more and more that we're looking into this, there is an extreme move right now to distribute the networking with computing capability all around the network. So this is something that is impacting us, but in a positive way. There's an awful lot of activities, and I think one reason we call it ourselves, for people who are new on the list, we call ourselves the GEMS, which is Jeffrey, Eve, and Marie-José. And the reason the GEMS wanted to have this interim was also to put a status on what is happening. Okay, next slide. So I want to have very briefly, or we want to have very briefly, a review of the milestones. I just kept the ones that we have not achieved, the ones for this year. I think for Vancouver, something that we could do is to start thinking of new milestones, again, because of the incredible amount of work that is being done in the research community on things that relate to what we do. I want to do a draft update. We have a number of active drafts. We have a few that are expired, and at least one that, although it's expired because of somebody getting a job elsewhere, I don't know what's going to happen to it. And we have one new draft that actually emerged from some work on IoT at the European Union. We want to do a review of the potential new work. And again, what's happening in meetings and conferences. I can see that a lot of my co-chairs of a number of places are on the call. We want to do the hackathon preparation, and that I think I will leave Eve to talk about some of the ideas she had. And also like what we want to do at the Vancouver meeting. And I requested more time so that this time we will have time to go through a lot of the actions that we have. For people who just joined, welcome to the call, and we will go through the agenda now. So next slide. So this is from the data tracker. The ones for 2019, we achieved them, which was like define what we want to do a little bit and get this group organized. So now for April, which is the Vancouver meeting, we have 3 milestones, which is identify COIN related ecosystem dependencies. And this is actually looking at some of the use cases. We had a number of drafts that were for that. 2 are expired, and there's a new one. So I think we're progressing on this, but obviously there's more work needed. The case studies, again, is that it's related to the previous one. And the one that I think that we need to really focus on maybe is, and Eve, you can, this is actually also part of your list of to-dos that you suggested, so interrupt me anytime. We want to discuss and catalog some of the COIN requirements and the implications for the network elements. Like I said in my little intro, we had at the beginning, we're talking almost a year and a half ago, which seems to be like the time of the dinosaurs. We were mostly looking at, implications in data center, a little bit of edge. And as this paradigm is evolving, and we even start seeing hop by hop protocols more and more, this distribution of computing and networking is very important. And I think this is probably the milestone that will probably not be achievable by April, but I think could be a focus for the meeting in Vancouver. Comments from anyone? I got you're quiet.
We're here. We're still here.
Yeah,
I'm waking up. I'm still waking up.
Okay, well, yeah, I think I don't know who else is from California, but we have to have kudos to Eve for supporting this at 6:30 in the morning. So, and I think it's not for today's meeting to decide, but maybe also regarding the new work and regarding the evolution, maybe we want to start thinking of new milestones, because the other one that we have is a very generic one that I think we had put last year when we started the group. And I think we may want to have, now that we're legit, to have milestones further down into 2021 and further out. And again, this is not for today unless someone has an ID for a milestone that we should add today. But I think this is something that we should have on our list of things to think about and things to do. And again, look at the evolution of the work from currently defined the drafts. As we said before in this group, is that the drafts are not the only output of this research group. We also want to encourage presentation from the research community, even if it is conference papers and stuff like that, to make sure that we stay really up to date with what's happening outside our group, and be able to better link to the other conferences and other meetings that are related to us. So I think this is an action item for everybody. Review what we have, and please think of new potential milestones that we should be discussing in Vancouver. And again, I'm going to come back to that, but I managed or I've requested to have more time in Vancouver so that we just don't have to rush through presentations, but have time to discuss things like the milestones and the evolution of the work. Comments from anyone? Okay, next slide. Okay, so these are the active drafts. There was a new version of the Edge Data Discovery, which was one of the earliest ones, but now has a new version. Eve, do you want to say something about it?
I would say that it was largely cosmetic. There were a couple of paragraphs that changed. I think we were wanting to not have it be expired, but what I'm hoping is that there'll be a more substantial change before the next meeting. You know, one of the questions that Dave had in his very thorough review of the document early on was, why focus on edge data discovery? Is there something more comprehensive from a life cycle standpoint that we could, you know, maybe that should be the focus of the draft. So that's the key point for discussion with the with my co-authors is, do we make that shift or not? So that's under review.
Okay. Okay. The next one is the industrial use cases. We have one of the authors on the call. Would you like to say something, Ike?
Yeah, actually, we're thinking about extending that draft or maybe submitting a new one, because we're now thinking about adding in some aspects about intrusion detection. So we've got a new colleague working here at our chair, and yeah, we're still in discussion whether we want to simply extend the security paragraph of that draft, or whether we want to do an additional draft about that.
Okay, nice. So you have the next two ones anyway, so that's fine. The directions for computing in the network, we do not have anybody from the authors list, but I understand that this is, you know, progressing, and again, it helped a lot focusing some of the ideas that we have, and so I expect this to be continuing. You know, one thing that I think in Vancouver that we think that we're going to start having is maybe accept at least one of these drafts as research group drafts, and this one is high on the list. So we will have, you know, a vote on this when everybody is there. The requirements for computing in the network, this is actually a subset of what's above. I think this one, again, we do not have any of the authors on the call. This one is, I think, a more in progress type work, and we will make sure to talk to the authors about how to make this evolving into something a little bit more consistent. Right now, it is a very generic list of requirements, and it would be great for the authors to focus on things that are specific to telecom operators, since they basically work a lot with China Mobile. Next slide. So the expired, there's one of mine, and I'm working with Alex Fayev and Lisha Shang to make a new version. So this should be reinstated. The next one was Jeffrey's. I think he will not continue this, but since he's not on the call, I cannot talk to him, but I had understood that they were not going to continue that. And the last one is a little bit like in a limbo one. Dirk Trossen, who is actually one of the main authors on this, has left InterDigital and is not working for Huawei. So I don't know if, and we will communicate with, he started, I think, last week or something like that. I want to communicate with him and the other authors to see what they're going to what they want to do with this, if they want to continue it or discontinue it or change the authors. And this is actually something that we need to review. There's a new one that's going to be presented. Actually, there's two new ones. We have one of the authors of the first one, Alessandro Bassi, on a reference architecture for agriculture 4.0. Alessandro had made a presentation in Singapore, and now I'm actually a co-author also on this, but it's mainly his work. He's doing actually the basic agriculture. Alessandro, do you want to say something about it?
Just follows the presentation that I gave in Singapore. So basically, it's putting those concepts into paper, and just to show how the computational network can be helpful in these circumstances.
Okay, and I have to say that it is actually related to the next one, which is to come. I don't know if anybody, no, there's nobody from Ericsson Research. There was a proposal at the European Union on the use of next generation IoT and a large number of use cases. And there was a recognition with Ericsson Research, and Dirk Kuchner was also involved in this, as well as the people from Intel Germany. And that there was this idea of a common data layer, this horizontalization of the computing in the network into layers. And this common data layer is interesting because it allows to address things like data formatting, data structures, advanced distribution, cognitive networking, and of course, security, which was, if some of you remember, one of the major comments that we got from our IAB review. I put it as to come because I'm actually right now in the process of recruiting authors for this, because there was a lot of really good efforts made in the proposal, and independently of this, if this is accepted or not, actually distilling the common data layer out of that is actually, I think, a very good idea, and can show that it actually makes all the silos that are currently part of IoT and a lot of communication system being connected together, and connected together very, very close to where the use case or the application is being activated or consumed. So this is to come.
And I think, Marie-José, that this is exactly along the lines of the comment that came back around the edge data discovery proposal. Because if you think about it, we're focused on finding the data, but that's only one part of finding data so that you can marshal it for to ready it for a computation that may be placed somewhere. And how do you do that coordination, for example? That was the thinking behind the edge data discovery draft. But then there's the equally important, okay, you have this computation, and what happens to it? What happens to the output of that? How do you name it? How do you maybe cache it in multiple places? How do you decide what's the best transcoding for it or transformation of it in order for it to be most accessible, et cetera. So I think that these have common issues, and so I am raising my hand to say, yes, I'd like to be part of that conversation, and see how we can, if not create a new, well, I don't mind if we create a new draft, but to coordinate when we're doing that.
Yes, and actually, part of what the questions were like, yeah, how do you discover, how do you coordinate, how do you orchestrate, how do you make sure that it's secure? There's a bunch. Actually, if I have the proposal we did and the discussions we've had with Ericsson and with Dirk is like we have a whole bunch of questions, and the discovery is part of it. So yes, and so I think this is interesting because also, and we have Ike on the call, and again, Alessandro is also there. These are basically discussions that were raised by this idea of the use cases in manufacturing, in agriculture, in transportation, where there is a functional distribution between cloud infrastructure and edge infrastructure and a bit of in between, and it goes into distribution of cognition also and all kinds of stuff. So I think this could be maybe at one point even more than one document, but let's see what we have. And it has raised a lot of interest anyway, so I think it's there. There's a bunch of people on the call that could have other ideas, and again, these are the ones that exist, or some of the ideas that are there. But there's other work being done in related fora. Actually, the common data layer is also very much related to things that are happening in things to things, for example, and even in named function networking. So there's a lot of common interest there. And if anyone on the call or in your research groups have other related ideas that you think could be interesting, please submit them. Again, I'm going to talk about what's going to happen in Vancouver. It doesn't have to be a draft if you just want to have a presentation. One thing that we have started looking at, and I see Frank is on the call, is this idea of critical information inside computing in the network. So by computing, we may want to identify critical information, and that information may need to be transported with some kind of FEC or some kind of coding. This is something that we started talking to with my other group, actually, the network coding group, with the people from the University of Louvain. And that could also lead to more things in the common data layer. So the criticality of information is, I think, also something that is very important for us. So again, good ideas are welcome, and the good ideas are not the chair's ideas. So please be welcome in submitting ideas. So anybody has a comment further? It's going to be a short meeting. Okay, next slide. Okay, so this is related to what just I said. So potential new work, we have obviously a use case for IoT. I talked about the common data layer. There's some ideas in distributed cognition. This is actually from Ericsson Research, and both in Ericsson Canada. I'm supposed to talk to them for the Canadian part tomorrow. But it is something that is strongly related to the some of the XR issues also. So XR being extended reality. So this is something that could lead to more work. Roberto Morabito, who is part of that Ericsson research team, is currently in Princeton. So he's talking to all the right computing and the network people. And that could be also something that's going to happen. Tactile internet, I am not seeing Faten Jani from École de Technologie Supérieure here in Montreal. I'm actually in Montreal right now, waiting for a snowstorm. And all flights are canceled tomorrow. And so tactile internet, and I would say other alternative internet approaches are also part of things that we can look at, because again of the necessary disintermediation of the functions and the location of their operations. I know there's other people from, I would say, the alternative internet architectures beyond ICN, which is very much related to what we do, but people related to other approaches to new ways of looking at the internet. And there's a meeting in France, I'm mentioning NetProc, where these people are going to be there, and I think there's going to be discussions there, people related to ARENA and also the Net 2030. I will have a shout out to my co-chair in NetProc, Eduardo Jacob, who has been immensely useful for this. So related meetings, this is my list, and actually one thing that I would like to submit to the list and to this group currently today, so raise your hand if you agree. I think it would be good to have some kind of a, part of the wiki, but maybe part of the GitHub, a list of conferences that we know are related to this. We all are involved. We all have our own list of conferences that we attend to, that we're aware of. And I think it would be nice to have a list of those, not just because it's fun to have, but also it would be a good way to communicate the ideas of the group, recruit more people to the group, and make sure that we're all on the same page. So it's not done, but I think it's something that Eve, Jeff, and I could start and ask the list for other ideas. So I mentioned NetProc. NetProc is in about now 3 weeks. It's in Paris. It's part of something that's called ICIN, which is a conference on computing, where there's going to be also a panel at the end on things related to computing in the network. NetProc right now is very small. We have a number of papers, but we also have a P4 hackathon/tutorial. It was the first year it was organized, and I think it's going to be nice. I like small conferences. There's a Dagstuhl seminar in March, and Dave and Eve and I, and probably a few other people on this list. I don't know if Colin's going, but you're welcome. I think it would be nice. And a bunch of people who are part of what I call the current team of drafts authors. Dirk Trossen, Jörg Ott, and everybody are going to be there. It's actually on Compute First Networking, which is one way of looking at computing in a network. These seminars are cool because it allows people. Okay, so Colin, you won't be there, but we'll take good notes. Those seminars are really cool because they allow people to really get together and be immersed for a few days into a specific topic. And they publish some, nice notes and stuff. And I think Eve is one of the organizers, actually, with Dirk. And I think we will make sure that salient outputs of this are going to be published to the list. I mentioned ICN 2020 just because I'm part of it, but also because there's going to be, we want to extend a little bit out of this year's conference, the concept of ICN, and going a bit into what Eve was mentioning in terms of discovery and some of the things that we have looked into, even for the this idea of critical information, where essentially who defines what is critical? Well, essentially it's the users of the application or of the system and the interest data messaging in ICN, and all the namespaces that were defined are really, really good for that. So we want to extend a little bit the focus of ICN 2020 towards these applications. Again, the other is for us to fill, and we will create this list and make sure that the whole community is aware. Anybody else having something? Eve, you're going to talk very soon, so I'm on my end of things.
Okay.
I'm sorry, we will not have real presentations today because we didn't get some, and also I think it was more the goal of this meeting was more to put a status for everybody than to have specific presentations. So next slide. Now I see only gray.
Yeah, sorry, because I was queuing up my slide that I was going to show. How's that? Are we back?
Yeah, we're back.
Okay, sorry. I have a slide I'll show, and I need to forward this. Okay.
Okay, so this is this is going to be Eve's show now. So the goal of the hackathon, like I said, we would like to have a common project, and this is what Eve is going to talk about. The goal is obviously looking at the architecture evolution and some tools development, but this architecture evolution, essentially also, it's interesting to think about it when we're inside the hackathon, because like I said at the beginning, it is one of the few occasions inside the IETF where all the groups can meet. And, you know, there's cross-table virtualization here, which is kind of interesting. So I will let Eve talk about her multi-stream processing project.
Okay, so let me stop sharing this for a moment. Are there more slides besides this?
I think there's only one for the, would you want me to do the last one and then you talk about?
Yeah, let's do that, and because
Okay.
I'll stop sharing this and then we'll come back to it. Okay.
Okay, so again, Vancouver meeting, there's the hackathon. I requested 2 sessions, or we requested 2 sessions, because in the last 2 IETF, we barely had time to present everything. And we didn't have time to talk about how we want this thing to evolve.
And that's a pretty common way that things roll out, is that we have these wonderful talks and then there's just not a lot of time for ruminating or for debating, and it would be great to have some breather between topic times and get people's opinions and responses.
Yeah,
So,
and that's why the first one would be on the research talks, having some invited talks, current and research topics, so that would, you know, generate discussions on where we want to go. Then have the actives and the new drafts, which then will be a shorter list, or maybe, well, there's still quite a lot. But also, I would say that having the research talks and the invited talks on one day, and then having the active and new drafts on another one, would also let people have the time, like what Eve said, to think about what's going on. And we will have time to look at milestones and to reevaluate a little bit where we're going.
right. And we'll try to schedule it in a way that makes sense so that we have presentations interspersed with discussion.
Yes. And the logistics, well, for now, you know, please send us agenda items and your talks that you would like to do. And so Colin actually sent a message, I don't know if anyone had, but there were day passes available, and if there's still some, but if you feel that, you know, somebody would not come if they have to pay the whole thing, or people from the West Coast at Vancouver is so close by. So, you know, students or things like that, or young researchers that sometimes don't have budgets, that could be a way to get more people. I think one goal of this group also, because we're like right now a little bit of, you know, that was my phone, and it's the Thunderbirds, by the way. And yeah, I'm a big fan of analog systems, so the Thunderbirds is perfect for me. So yes.
Okay.
So just to follow up on that, there are a very limited number of day passes available. It's an extremely limited set we have. So this is not a we can hand out free passes to everybody thing, unfortunately.
No.
So tell those who, you know, tell your friends who are not who might not be able to afford the registration, particularly students and other researchers who might have limited funding, that these are available and that they're going quick.
Yes. Also for students, there is a very cheap rate to attend the whole IETF week.
Yeah, I know. Okay, so Eve, you can now talk about your.
Okay, let me stop this. I want to show another. I'm going to stop, see if I can stop sharing. And then let me see if I do this again. I'm going to bring up a slide. Here it is. Let me know if you can see it, and I will put it in.
I see it, and it's beautiful.
Okay, so for those of you who might have begun attending these meetings way back when we were in Thailand, I participated remotely, and I was representing, in fact, that first, it was a BOF meeting, and there was a lot of presentations about use cases with traditional, what I would call traditional flows of IoT information, which is data comes from the backend cloud and wends its way towards the edges of the network. And I sort of showed up and said, well, one of the reasons why I think compute in the network is so interesting to me is that if you look at other use cases, a lot of data is getting created at the edges of the network, and it aspires to to send itself upstream. And if every device that's part of some very large group is sending data, not just even control messages, but data upstream, there's an implosion problem. There's an even more pronounced implosion problem, which, voila, I had to use some French, Marie says, it's very likely that you're going to need to scrutinize the streams that converge at various collection points to assess whether it's going to fit, all of that data is going to fit on the next hop going forward. And not only is it going to fit on the link, but it's going to fit on the computer, either in memory or in storage or on it, its internal bus, whatever the case. So compute in the network has this, this role for these upstream flows to, assess the resource availability. And it turns out that if you look at a lot of the immersive media work going on, or even the dense IoT work happening, we've got so many dense deployments of devices, whether those devices are cameras or sensors, that, in the aggregate, when they collect at points, there isn't enough room there. So what are the kinds of functions that need to live at those aggregation points to do interesting things? Now, while I sort of introduced this case of these upward flows and this need for compute at those nodes in the very first BOF session, at a later session, I actually came in and talked about I guess, and not only in again, you can hear I'm not quite awake. It's still early for me, and I haven't had coffee, so I'm not finding my words. But I've also presented this work not only in COIN, but in the ICNRG work around what we've been calling the ubiquitous witness use case. And this is the idea that in these dense deployments, there are so many witnesses to any event. So I, as a sensor, may sense something anomalous happening, and I believe I've used the use case of, in a smart city, there's a camera and something of importance happens, like a crash in the middle of an intersection, which is actually where the bulk of most accidents happen, or a very large percentage of them. And, so it senses that, but by the way, so do all the other sensors nearby, whether they're cameras or vibration sensors or audio sensors, and they're all sending information to their anomaly detectors. And so the idea was, for this ubiquitous use case, what are the kinds of functions that that you might perform at that collection point? So what I have here is somebody's rebranded Tofino switch at the bottom. And it presumably has match action. I don't know if you can see my cursor. Can you see my cursor moving around when I move it? Rose?
I do.
Okay, great. So, it, of course, the programmability is all about these match action tables, at least from a programmable switch standpoint or a P4 standpoint. And I started a thread, I think right before the last, or maybe right after the last meeting, the last IETF, around what are the kinds of things that your switch what could it do to not only assess whether a single flow matches some rule, but could we have groups of streams, have functions that are very deliberately looking at, in this case, I've just for example's sake, A, B, and C, and I should probably show this more visually on this picture, but A, B, and C are streams, they're flows, they're data flows coming through the switch, and I really want my match function to be about, can you tell me if these streams are contextually related? And that begs the question, what does that mean? And so in this dense IoT deployment use case, it means that you might be proximate to each other, and not only are you
Can I ask a real quick question?
Yeah.
Who is me in that previous sentence? You said, can you tell me?
Oh, from the perspective of the switch, because this is, of course, going on in the switch. And this is a function, this is, and that's a great question. These are match action functions that need to be installed. And so I guess the answer to the me question is whoever's installed the match action function. But it may be an operator, because what I'd like to have happen is I'd like to provide a service. This is the use case that I've presented in the past. I'd really like to have a use case where I say, one, what are the flows coming through this switch that are proximate to each other that might qualify for a contextual compression, which is not, and I use that term loosely because it's not compression in the sense of like, I'm going to take my favorite encoding scheme and compress this, but rather, because of these streams being related to each other, and they might be providing me redundant information, I have this opportunity to say, only forward the information from the stream that has, and this is what I proposed on the list, if I could ascertain that these streams were related, meaning they're sending me related information. You could define contextually related in any number of ways, but in this use case, it's how proximate are they to each other? Are those cameras pointing in the same place, and have they actually captured, the jaywalker who was walking across the street that led to this accident in the middle of the intersection? Something to that effect. And so I'm thinking about all the different things that once I've ascertained that these streams are related might be useful functions to match on. So these were just, top of mind examples of what my match function might look like. But note, all of them are on these incoming groups of incoming streams. So again, I'll annotate this slide for our meeting in Vancouver so that this is a little clearer. These are on streams, and the switch is needing to look, very likely, although not necessarily, very likely I want it, certainly in the second example, to look into the packet beyond the packet header. So right now, it's often the case that what's happening inside of the switch is that it's got acceleration hardware for doing all the things that are typically done to packet headers as they come in. But really, a lot of the most interesting, my perspective is there's additional interesting work to do and could be defined as compute in the network that happens beyond the packet header. And so not only are we interested in groups of contextually related streams, but we're looking at wanting to process stuff beyond the packet header. Is there a human in the frame? Is there an anomaly detector? All of these things could be about information that's in the deep packet inspection. So, I don't know how easy or hard that is to do because I don't really have my P4 chops yet. But but that's the thinking. And then the action might be something as simple as, you know, oh, these things, you know, I want to process them together and I'm going to do more sophisticated things on them. Let's, you know, spin up a VM and do something more sophisticated with them. And we're using the switch to kind of identify collections of things. If you squint at that, that may look like, I'm forming this virtual edge cloud. Those streams qualify as some federation in its own right, and let's, you know, do something edge-like that manages, for example, I'm going to have establish some policies that are related to those streams, or, you know, I'm going to identify where there's a trust anchor for them, or other forms of security and privacy. For example, it may be the case that, oh, I've got these contextually related streams. Let's turn on that anomaly detector, and so that I can come back and do some anomaly detection. Oh, and then there's anomaly detection. Let's turn on the, you know, human in the frame finer grain anomaly detector, or something like that. So you can see there's this, whoops, that was not what I wanted to do. Hang on. So there's a whole collection of these functions that are circular or iterative. You know, one leads to the other, which comes back to a different kind of match. The match leads to an action, which leads to a match, which leads to an action, and so forth. But I'm also quite interested in, you know, if something happens that's anomalous, you can imagine in an industrial setting that you might want to vault that data, or even in a setting where there's a business model around, there's an insurance, somebody needs to, you know, or there's a contract for a guaranteed quality of service that isn't met. I want to vault the data so that I've got evidence, my ubiquitous witness evidence in the future of some collection of data around a point in time and space. And then, you know, back to the immersive use case, the immersive media use case, and I have in the past also commented on the very interesting work going on in the MPEG standards community around stitching together these disparate streams of flows to form something new, which is, you know, 360 degrees. There are whole collections of formats and point cloud formats that are emerging from the MPEG-I group. But the idea is, I have all these streams, they're related if they're in the visual realm, and I could stitch them together, or even to view partial 360-degree views, you know, maybe it's a 180-degree view, that would still allow me to walk around my data after the fact and examine what actually happened. And so you can see that there's this, there's no shortage of things that we could do for this kind of use case. The question is the switch up to it? And what would, you know, do we, or is the, if it's not the switch itself, are people interested in these kinds of use cases that might anchor a demonstration at a hackathon? So I will stop here and kind of wait for your responses.
So I have two quick observations. One is, some things are convenient to do with the data flow model, which is what you're basically forced to do in a switch.
Right.
And some things are not. And I think like a first order thing to try to do is to categorize those things, because we have 50 years of history of what things work well in data flow models and which things don't, just from a computational standpoint. So maybe going back and looking at that kind of stuff would be useful.
Right.
A second thing, which happens at much higher data rates than what we're talking about, is what the physicists have to do for detector data in particle accelerators. Because they have to combine and throw away more than 99.99% of the stuff coming in. And figuring out how to do that without, you know, spinning special purpose hardware is actually very, very tricky. So there may be some learnings there.
Yes, I mean, that's a really great point, because make no mistake, you know, I show a picture of a switch here because we have, at least in the past few hackathons, been catalyzed by looking at P4. And so it's more an entree to the discussion. But the question is, this is not just a software flow or a programmability flow. There are implications for the hardware, which are super interesting for the design of any kind of entity that lives at these aggregation points, because there is this close partnership that has to happen between the router, the compute engine, and the storage that may not really exist as yet in something like the switch that I've shown here.
Yeah,
It may not be a switch at all, you know?
I agree entirely with that. The
Yeah.
one caution I would give is that P4 is way more powerful than any switch today can do, and maybe way more powerful than any switch that looks anything like today's switches could ever do.
Right. So maybe it's,
I think you really need to start with the hardware and not the programming language. I can do almost anything in P4 if I want to.
right, right. But you know, the point of this is to identify what can't the hardware do. I mean, so that's we talk a lot about. You know, we've been thinking a lot about the programming, but I think some of the implications of the compute and the network are absolutely hardware based, and they will lead to new kinds of architectures for how the three-headed beast gets along, and I refer to that as the compute, the networking, and the storage of the three-headed beast, and whether it's that we're adding compute and storage to the networking elements, or, and I know you've raised this in the past, Dave, or whether we're adding network elements and compute to storage or so forth. You know, these are probably, they're all valid forms of architectures, but they all are going to have this problem that they're going to want to take on capabilities that live in the other two domains, or the other two brains of that three-headed beast. So, yeah. So
right. I mean, I think you're exactly right on. The danger we follow is starting from what a switch can do, as opposed to starting from what our architecture and protocol designs ought to be for in-network computing.
well, I'm happy to, again, because this sort of came up in the context of the hackathon. Could we come up with a project that was more long-lived, that maybe, you know, for this kind of hackathon, the first thing that we look at is how easy is it to simply do the base function, which is could the switch at line speed tell me which things are contextually related, and could we come up with a family of functions that do progressively more sophisticated you know, functions around what does context mean. You know, it could just be an identifier inside of the packet header. Well, that's simple. The answer is yes. But, you know, these more sophisticated ones, the answer is probably not. Now, to drill in a little further into the use case, and again, I can kind of present this in more detail in a, you know, when we meet in person, that one of the interesting things about the MPEG-I standard is that it's got a metadata description for scenes. So if you think about what your camera's looking at, and there's a scene description of what's in a frame, that's cool. But you know, what does that actually look like? Well, you take a step back. What's all the objects that are in the scene might have in turn their own descriptions. And so this starts to look like some of the conversations that are going on inside the thing-to-thing working group. If anyone's been following the Wishy work, which stems from the workshop on, I can't even remember what Wishy stands for, but it was all about semantic interoperability. And there's been this great partnership between the IETF thing-to-thing working group, the OCF, organization, and W3C, and a whole slew of other IoT-related standards bodies and consortia to come up with one data model for, like, how do you represent data, how do you represent objects, and so now you've got MPEG-I. It's got scene intelligence. It can recognize, if we throw some, you know, we can create bounding boxes around things and identify them as objects inside of these scenes. And each one of those objects in turn has, its own meta information. And, it starts to look a bit like the naming that's required for ICN or some other complex scene where data is related. Now, not everything in a scene is going to have a digital, is not going to have computation and communication capabilities, but some of them are. And it just becomes a very interesting way to link the visual realm to the smart objects realm, and kind of working backwards to figure out how do these digital cyber twins, that have a representation on the computer, then map back to the physical world. So there are lots of things that can come out of this. It's sort of endless. But in that case, I was thinking that it could have some nice implications for linkages back to where the COIN discussion even started, which is the thing-to-thing research group. So, so kind of to come full circle, is this, sort of how do people think about centering at least one of the hackathon projects around a use case like this, whether or not we tie it to a physical switch, or whether, all of this lives in software of some sort, and we map it back to these, what Dave was saying is, what are the kinds of functions for contextually related data flows that are easy for certain kinds of classes of hardware to do versus these newer functions that we're going to need something new for. So we absolutely could go through that exercise, but I think it would be quite interesting. But that's me. What do other people think about this as a hackathon anchor to some of our work?
So Emil is there and Alessandro is there, and as the one who was there at the past 2 hackathons we had, I would say that what was done in Singapore, for example, which was, I would say, a single stream match and action. Actually, we have the code for that already, because this was done in Singapore, so there would be something to start with. On the comment of David, and also what you're doing, this idea of, identifying the anomaly detectors, or identifying information out of a huge amount of data. The physicists have it even larger than most people, but Alessandro could say that, for example, in the agriculture use case, where there's going to be time series of pictures that are going to show infestations or the growth of the plants or whatever, there is also an awful lot of information. It's like big data, essentially. And 99% or even more than that is just data that could be sent somewhere else and used to train neural network algorithms. But they're not, I mentioned the word critical, and they are not critical at this point. They're part of, yes, the training. So this is what a nice plant looks like. And oh my God, now there is something that needs action. It still needs to be part of the training, but it also needs to be actioned on right now. So it's the anomaly detector. It needs to trigger something. So I think, yes, the implication in MPEG is interesting, but I think the more, the even more important one is this in-network compute across contextually related data flow. And I think, based on what was done in the past 2 hackathons, is something that is a step further. Emil or Alessandro, you were there in Singapore. Do you have anything to add to this? Okay.
You're on mute.
I know they're on mute.
They may not know they're on mute.
I'm muted, right?
Now you're unmuted. Yes, we can.
Okay, good. No, but what you said is it's very true. I mean, related to the data, coming from different fields. Agriculture is one of the examples, but industry can be a similar one, transportation or whatever. Smart city and so on and so forth. And indeed, I mean, that would be very, very interesting for me.
Okay. So I think what
there's another angle that I think we ought to be aware of. Nick McEwen gave this fascinating talk at HotNets in November. And the bottom line of that talk is that servers are starting to have the same problem as switches. Because if you need to touch the data, everything falls apart very quickly at rates above 40 gigabits. So he's actually proposing new server architectures where you can't actually look at the data. You can only look at the packet headers in the servers and decide what to throw away and what to allow to flow through your cache into main memory. So I think we're going to see a lot of this recapitulated, and two things we really ought to think about are, number one, the switch guys really don't care about anything but the highest rate data, right? All of their energy goes into it, all of the money goes into it, all of the ASIC design goes into it. And we have tons of use cases that are 2 orders of magnitude below what those guys are looking at.
Yep.
And we can do tons of stuff in software and don't necessarily have to live with the restrictions of the way people build switches, which is to put a really fast forwarding ASIC on it and a CPU that's 10 years out of date. So I'm glad the group is taking this broader look at how to deal with computing in the network. And we shouldn't forget about the vast majority of applications that do not require the highest speed tiers.
No, and I think that's exactly what I said at the beginning, when I said this has been an incredible evolution of the thinking of this group from the big, from when we started thinking about it. And, I would say, well, poor Jeff is not here, but Jeff had more of a data center, hundreds of gigabits per second or whatever. And Eve and I were more like, oh, hold on, there's also a need to do things at a lower speed. And I think both still live. And while the hackathon is still looking at what we can do with P4, we're not linked to it. We're not wedded to P4.
Yeah, again, I don't think P4 is the issue.
No, I know.
You can change the stuff in P4 that nobody's ever going to build a switch to be able to do that.
Yeah. So, but what I'm saying is that I think all these comments are good, but maybe if, I think, Eve, you should post this slide to the group and with a little bit of your ideas and see how we could do that. And like I said, there's already code from the previous hackathon that does some of that. And also start a discussion on, yes, what it means to look at these data flows, what it means when you start looking again just at the headers, or I would say a little bit beyond the header, I would say the header and the metadata, and not just, the whole, we don't maybe need the whole payload to make a decision.
Right. And actually what I didn't get to was that it turns out, not surprisingly, that the MPEG-I standard creates, voila, metadata identifiers, so object identifiers. And so in the same way that we may have a port number or a source address or whatever, it's got metadata identifiers. And maybe what we could be doing is simply jumping into the packet and grabbing that metadata identifier to go, aha, you're looking at that thing too, and okay, great, we're contextually related. So those are some of the conversations that we've been having internally around how to leverage a concise way to figure out whether we're looking at the same thing.
Can I ask a question, Eve?
Yeah.
This is going to show my total ignorance of MPEG-I.
Okay.
MPEG-I is actually capable of creating common object identifiers across sources?
No, that's what we're doing. But reusing the identifiers. And so again, this has wonderful implications for, you know, the magic of namespaces, and could we leverage our expertise in namespace design to do something intelligent in the MPEG world, or propose something or demonstrate something?
Okay, yes, fine.
No.
Let's take MPEG-I as it is and figure out what we can do with it, because I'm not nearly as optimistic at that.
Right, but so this is, but this kind of goes back to, okay, because MPEG-I is in flight, just as the one data model work is in flight in the IoT, can these communities, which seem like pretty disparate communities, can we get some people like ourselves who straddle these worlds to influence, one, the metadata model, two, how would it be easy to extract from these scenes, create namespaces that are reasonable and processable, and et cetera, and that fit into these models of networking like ICN and so forth.
So, another sort of thing right out of my rear orifice is that about 8 years ago,
that was a great phrase.
Aditya Kell and his group at Wisconsin came up with a scheme for fingerprinting video with similarity, algorithms that actually represented similarity. So that if you computed this at 2 different sources, it would come up with the same fingerprint if the 2 things they were looking at were sufficiently similar.
That's excellent. That's exactly.
I want to go back to that work. And
so that's Aditya's work?
Yeah, it was him. He was the PI. I'm not sure he actually did the work.
Okay.
We should go do some forensics on video fingerprinting.
Okay.
Because that sounds more like what you're trying to do here in terms of being able to decide what to do with some video based on how similar it is to some video from a different source.
Okay, but let me reframe this, no pun intended. I really, the thing that I think is important, and I think where Marie-Josée was going when she was making reference to the previous hackathons and other people's work and code that we have already, is this hackathon, we should focus on what does it mean to be contextually related. Now, if your data streams in the video realm, great. Aditya's work could be very useful. But this issue of ubiquitous witnesses, where we've got dense deployments where sensors are sensing the same phenomena, we could come up with a whole family of functions that qualify as contextually related functions, functions that will deduce whether or not some collection of streams flowing through your network element are contextually related. So,
yeah, but I think there's two. I mean, these may be extremes, but many of the cases in IoT are actually static properties, not dynamic properties, or quasi-static properties, which means if the configuration of the sensors doesn't change, the contextual relationship doesn't change. And that's not true for video.
You're right that there's going to be some classes of meta information that never changes. And then when we've got mobile things moving around or dynamic scenarios, yes, that part of the metadata space is going to be, very hard to tame, because it's going to require you to do some computation on the stream before you can decide what the metadata is, that you're going to plug into this function that's going to deduce contextual relationships. So yes, I think that's one important point that to tease out of this is, could we find interesting elements inside of the metadata that after some initial compute, or even from the get-go, are things that we could hang our functions on, meaning, that's what we focus on to deduce contextualism. And that would certainly speed things up. So, that's sort of a meta problem for this is how do we create this family of functions that don't require us to perform compute every time, because after all, it's certainly for these style of switches or network elements, they're not really designed with hardware that's going to be that'll accelerate those sorts of functions, at least not yet. So, yeah. So that was a good point that you made, Dave, about what things are we going to look into the packet stream and grab. How easy will that be? And that should be the focus of, I think, the hackathon, is just to do something really, this is the big picture, but the small picture would be, great, let's work on functions, some small collection of functions that'll figure out whether these streams are contextually related that are flowing through the switch. Now, we don't really have a test bed that's going to allow us to do that, so we're going to have to simulate that. And I'm not exactly sure how we go about doing that.
Well, I think that's what I think would be interesting in starting a discussion on the list, because the people who were really influential in the previous hackathons are not on, well, Alessandro and Emil were there, but you know, the people from Noviflow, the people from the university in Singapore that did a lot of fantastic work, the guy from the Netherlands, who I suppose was part of one of the telecom operators there, they're on the list, so they could also have specific ideas for this, and I have their names anyway, so we could even pick them personally. So that's what I say. I think you need to capture what's on that slide, how it relates to a number of use cases. Alessandro is very big on these digital twins, how we can look at that. I think, Dave, it would be great if you could post the paper that you were mentioning to the list. Maybe you did, but since we're talking about it.
Oh, and also.
You mean Nick's thing or the stuff from, I have to do some forensics to find the old fingerprinting stuff.
No, the paper you said was presented at HotNets or something like that?
Oh yeah, that Nick McEwen's.
Yeah, I'm not sure it may have been a chalk talk. I'll go look at the HotNets proceedings and see if it's in there.
That would be great.
That'd be
I know you've mentioned it in the past, and I think I've tried to find it, but I haven't been successful. So.
Any other comments from anybody else? Okay.
Okay,
So,
I'm trying to figure out how to stop. Okay, so I'll stop sharing. Okay.
Maybe you just want to put the last slide just that I had just to conclude.
Okay, let me grab that again. Share that again. This is good. I've never had to share stuff in WebEx before, so this is good. I'm learning.
Okay, so I think I've taken a number of action items. One of them is to make sure that we share all these ideas for the hackathon for March 21-22. As far as the active, new, and expired drafts, I'm going to make sure that I contact the authors of at least the Dirk Trossen one to make sure to see how this is going to go forward or if it's going to be abandoned. I'm going to work with Alessandro on the use case for agriculture. I will contact the Ericsson research people as well as the people from Intel Germany about this common data layer that was defined more or less both in discussions for the EU proposal, but also a lot of it on side meetings that we had, and also that involved Dirk Kuchner. Actually, it's very funny to have two Dirks in the same group. So it's Dirk T and Dirk K. So this one at Dirk K. And we'll obviously use all of this to define agenda items and talks. We already know, by the way, that there will not be potentially anyone from Huawei or from China Mobile in Vancouver. I just got another email while Eve was talking. So we will make sure to have a lot of remote participation possible so that we don't lose the collective intelligence and the collective research from China. And
hopefully people will be tuning in remotely if the time permits it.
And I think for them, Vancouver is not that bad, actually. It's I think it's 9 hours, not 12, like if we were on the East Coast. So, it's feasible. It's like you, Eve, when you communicate with Europe. So I think there's potential for participation, and I'm even thinking that if it gets to this, we could even have them record their presentations and just play it back. Obviously, it means that all questions would be then taken down and sent remote, sent at a later time. But I think we have to make sure that we allow people to, to participate as much as they can. I also know that out of the NetProc, we're going to also contact a few people. There's ways of also having more presentations. As you know, the Cambridge group in the UK is extremely active on all kinds of related things. I also know.
Can you tell us how are we faring with regards to, like, do we have certain topics approved already and time slots spoken for, and so we know we only have X amount of space left? No. So nothing's been, okay. All right, just checking.
All right. That's what I say, call for agenda item and talks. I think you, Eve, and Jeff, when he feels better, should start working on the agenda. But for the moment, I kind of call it like a call for agenda items. There's nothing
perfect
planned, except for obviously the people who have the active drafts obviously should be given a chance of presenting. But the rest is wide open right now.
Okay.
And yeah, and I think I think we're going to have still a lot of stuff. And but I think with 2 sessions, we should be good. So hold on, there's somebody at the door here. I need to go.
So maybe now's the time to say goodbye.
So before we say goodbye, I
pasted
some links into the chat room for Nick's paper and a couple of these fingerprinting papers.
Oh, okay. So then I will not disconnect until I grab them.
Yeah, the 2 fingerprinting papers, it's not quite obvious that they're related, so think about them a bit, because they had a different purpose. But the hard part is getting the underlying algorithms for data similarity right. Right? And that's the hard part, not the networking part.
Yes, I totally agree, which is why software-defined, computations, like, well, how do you figure out how long that computation is going to take if you're dynamically loading different computations in, or if similarity is, an order of magnitude takes longer because there's so many more things in the frame, or, there are a lot of variables.
Right, and at least one of the papers, the algorithms were offline algorithms.
Oh, cool.
But the other one, the video one, I think the intent was to be able to do it at least at user interaction rate.
Good.
Okay.
Okay, and thank you very much. So I recorded it, so I will be able to send this to Jeffrey, and I think this is the last question, Jeffrey. Hang in there. It's probably not very easy right now in Zen. So
thank you, everybody, for joining the session.
Yeah, and thank you, everybody. And I think I can express my own. My own sentiments here. This is going really well, and it's blossoming, and it's really cool. And thank you, everyone, for being there. We had, I think, a very good cross section of skills in this meeting, although it was small. And I think we need to continue the work. So thank you so very much, and thank you to Eve for being the early bird. I hope you catch the warning.
It's okay, all worth it. Thank you, everybody.
Okay, have a good coffee now. Bye.
Thank you so much. Bye-bye.
Bye-bye.
Thanks and bye.
Marisha, I'm going to stay online if you